welcome to In Conversation. Today we're going to be talking about MiRo in education, particularly in schools. I'm Izzy, the Product Director at Consequential Robotics, and here are my guests, Professor Tony Prescott and Dr. Melissa Butt. Would you like to introduce yourselves quickly, Tony?
Yeah, hi, I'm Tony Prescott. I'm the Chief Scientist at Consequential Robotics and a Professor of Robotics at the University of Sheffield, and one of the co-inventors of the MiRo robot.
And I'm Melissa. I am the founder of Discovery STEM Education, which is a not-for-profit educational organisation. I'm also the chair of World Educational Robotics in the United Kingdom and a co-founder of Invent Future Global, both of which are global educational programmes for young people.
What a resume. And today we're going to be talking about using MiRo, the adorable robot you can see in Melissa's background. I've got one here as well. And MiRoCLOUD, which is our online educational platform where you can code with MiRo, simulate in a MiRo environment, simulate a MiRo even in an environment, and you can do all of this fully online with just a click of a button. Great. So Melissa, to start, what are the challenges for teaching robotics or coding at the moment, do you think?
So for teachers working in schools who we tend to spend a lot of time working with and supporting to incorporate STEM programs into their learning, time is one of the big constraints that teachers have. So to be able to undergo teacher training and become an expert in robotics is one barrier, especially when they have so many other things that are priorities in the curriculum at the moment. The cost of having to have usually lots of physical robots in a classroom can also be a barrier for schools as well. And now there's the barrier of the COVID policies. So children actually using equipment now poses lots of extra challenges that it didn't have before. And sort of having a coding platform that is attractive to young people and easy for them to use, and accessible curriculums for teachers to use as well. And they're the main things that we see when we're looking into barriers for robotics in education.
And why do you think robotics, or in particular kind of coding, is important, especially at such a young age?
We can see that as the world is changing so quickly and coding and robotics is coming into so many different areas of the workforce, and it's really looking like the future careers are going to require some level of coding or understanding coding. So it's really important that our young people are able to develop those skills from a young age. But what we've found with the children that we've worked with and with working with teachers in schools as well, is that when children are learning coding, it's actually supporting them with other areas of their learning as well and helping them to develop other skills as well. So coding really does support children with their development of other languages, because at the end of the day, coding is another language. And also with science, because coding involves a lot of scientific thinking and problem solving and thinking in a scientific way. So coding also really helps support young people in their science learning as well, and mathematics as well. Applied mathematics, really the problem solving and the coding and coding algebra. So coding is really helps to support young people in mathematics as well. But one thing that we've been really surprised with recently is a school teacher, primary school teacher, who told us that he did half a term of coding in his technology afternoons with children. And then the following half term, he moved on to teaching them how to read music and learn how to play the piano. And the children really found that their coding, they kind of saw this similarity between the coding that they'd done in the previous term, and then kind of said, well, this is also coding, isn't it? Oh. It's just another kind of coding. And so he found that it helps them, and it was complementary to their music lessons as well, which was really interesting. So it's not just coding for coding, but it actually helps young people to develop lots of other skills as well.
I mean, I wish I'd learned it, especially with you when I was a bit younger. Never could play the piano. Tony, you come from
music has its own grammar and rules and patterns, so there's similarities, definitely. Yeah.
And in biology as well, DNA sequencing, so yeah. Genetics, it's all coding, isn't it?
Yeah, absolutely. Yeah.
I mean, Tony, you come from a kind of higher education background, working primarily in universities. Do you find the kind of same things as Melissa does? And
so we've started using MiRo code in level 1, and also actually with our third year students, level 3. With level 1, we're finding that the interface, which allows you to use visual programming language, Google Blockly, really helps the students, because there's such a diverse range of students. Some of them have done A-level computing, some of them have done no computing. I'm in a computer science department, and so we want to start everybody from the same place. And so we're using the MiRo code and MiRoCLOUD with our level 1 students, with classes of 300 people sometimes using MiRoCLOUD all at the same time. Maybe I could quickly show a MiRoCLOUD here. I've got it running on my computer.
that'd be great.
So so this is the MiRo Cloud window. Can you see that?
Yep.
So this is, so you get into this just by opening a browser window. So I'm running Google Chrome, and what you have here on the right is the simulation of MiRo, and I can zoom that in and out. There's MiRo sitting there. There's a pile of cans, and it's a full physics simulator. So that's one of the exciting things from the perspective of teaching, is that you get all the physics of the world. So if MiRo does something in simulation, it does it quite accurately, and it's quite similar to what would happen in the real world. And then this is what MiRo sees down here. You can see these two windows. You can stroke MiRo on the head in the simulator. And of course, the robot can detect that input because it has touch sensors.
And you can see it down on the bottom there, light up in green.
Exactly, yeah. And if you make a clap sound, you can see the microphone here light up. So let me just stroke MiRo on the back this time. Yeah, you can see the light. So those are all the touch sensors on MiRo's body. And when you stroke it, you see those light up. And then there are a bunch of pre-written programs. So this one will have MiRo just go around it in a square. And I just run this program by clicking play here. And this is the Google Blockly. So it steps through these colored blocks, and kids build their own programs. You can see this one has a repeat loop, repeat while such and such is true, and do these several things. And those several things involve moving and turning. So it just does a square. And you can see that what MiRo sees through its two cameras changes in real time as he's moving. So the sensory input is tracking what MiRo is doing. And then I can stop that there. I could, if I had a MiRo here, now click on play and run it on the physical robot that was sitting on the floor. So I could have my program, my test installation, and then run it on the robot, which I think is really exciting, because one of the feedback we've had from schools is that with some of the other robots, you just program the physical robot, there's no simulator. So if your code doesn't work, it takes a while to find out, because you have to put it on the robot, run it, and it doesn't work. Whereas here you can test it in simulation. You know it works in simulation, you get quick feedback about any errors, and then once it's working, you can try on the actual robot. So this, the Blockly, there are lots of commands here to make things happen. So you just drag and drop these boxes. So that's a quick introduction to Google Blockly.
And I can see that it says Python. Do you want to show us quickly the Python screen?
Yeah, sure. So so the kids can write in Google Blockly. More advanced kids can, or students can write in Python, which is, it's the standard language. Whoops. Yeah, I think I'll say okay to that. And then this is the Python code. And this is what we also teach our level 1 students. They learn to program in Python at the same time as they're doing Google Blockly. So as they are learning Python, they can also see this mapping between the visual programming language and the coding system that they're learning to use. And of course, Python is a professional coding language. It's a very popular coding tool. So it's a great one to learn in terms of jobs.
Wow, looks great. I mean, Melissa, do you have any experience with the teaching of the Python? Do you think it helps having both of the different options available there?
Well, we've been really surprised because we've developed 12 lesson plans altogether in view of the teacher training that will be starting next month for UK teachers. And so far, all of our lessons have been based around the children learning how to use the blocks. So each lesson is about learning how to use a few different blocks and to solve various problems related to real-world medical problems. And what we found is that children from the age of 6 have written their codes in blocks, and without us mentioning the flip or talking about Python and how you can convert your code into Python and what Python is, they've started to explore themselves, and some of the children have started to flip over and say, look, this is how you would actually write this in Python. The blocks that I've done, this is how you would actually write it. And we haven't planned lessons on Python yet. That's supposed to be coming later on. So that was really impressive. But then some of the older children have then taken it to the next level. They're not just writing their code in block and then having a look at the Python equivalent. From that exposure, they've now been able to figure out what some of the code is for some blocks, and they can see where the numbers are that they would need to change to make MiRo do something different. So they've now started to write their code in Python rather than using the blocks and then looking over to see what the Python equivalent is, or rather than just doing coding in blocks, they're starting to do some of their coding in their classes just in the Python area and writing the Python coding, which is really impressive, not what we were expecting at all. So we need to hurry up and get our Python resources ready.
It's lovely how the sort of the learning experience is very student-centered there, so they discover stuff for themselves, and rather than being told you're now going to do this in Python, they find it out, and it's exciting and interesting because they discovered it themselves.
Yeah.
And I was wondering also, there are really some quite sophisticated programming concepts even in the Google Blockly. For example, the idea of a variable, something that maybe has a name like X or something, but stands for a value that can change. And do you try and teach those sorts of concepts with MiRo code?
Yeah, so in the sessions that we've developed so far, there are sessions that cover things like variables and conditional judgment. So we don't go straight into the coding. We need to first of all do some groundwork on explaining what those things actually mean. So we get them throwing balls around to learn about variables and conditional judgment, doing some role play. And making some examples up of my mum will let me go outside if I wear my coat. If I don't wear my coat, she will make me stay inside. Sort of learning what those terms actually mean, first of all, and understanding what a variable is or a conditional judgment for young children. We've got children from the age of 6, then that's some great learning already. But the children are now able to move on to coding for variables and understanding what variables means in their coding in MiRo code, and understanding what conditional judgment is, and being able to do lots of different things, and then also explain it back to the rest of the class and do their own talks on, I have solved this problem by using conditional judgment in this way. So we know that they thoroughly understand it because they're developing their own things and then they're explaining it to the rest of the classroom. So yeah, we are definitely, we don't want them to just be doing very basic coding. We want them to learn and to stretch them to understand those real terms.
It's incredible. And do you find the actual having the physical robot MiRo as well, being able to simulate it and use it, do you think that's kind of improved your students' learning?
Yeah, I mean, we've had to do quite a few online classes, and the simulator has been fantastic for that, because even without a child being able to see a physical robot, well, they can see it through our screens, but not being able to interact with it, they are able to see the results of their code using a simulator, which is fantastic. But when children have been in our centre and they see MiRo, they come in, they all want to interact with it straight away, because usually robots that are aimed at young people tend to look like Transformers or cars, where MiRo looks like a very cute pet, and there are very few young people who don't gravitate towards a cute looking pet. So they're automatically engaged. And we found that on our holiday programs where we get a real mix of children, they're not coming to a specific robotics class or a specific invention class. In our holiday programs, they're coming for the whole day, and they get they get a variety of activities. Some of them are based around invention, some engineering, and some robotics and coding. And usually you find children prefer one particular thing, either invention or robotics. But when we've got MiRo out, the whole class wants to come and interact with MiRo. And then naturally from that, they want to see how they can make MiRo. They realise that, oh, it's got lights on there. Sometimes there's a light that flashes. Can I make all the lights flash? I want to know how to do that. We've even designed some sessions where they need to code MiRo to do Morse code in a hospital where the electricity is gone. And so it's been in the evening classes as well, that has actually, so it's been really exciting. It's been really dark, and there's just this MiRo going around doing Morse code, flashing different coloured lights, lots of different coloured lights going around our centre. The parents are outside thinking, oh my goodness, I sent my child to robotics class and they're just having parties here. But so naturally they want to then figure out how they can manipulate MiRo and get it to do what they want it to do. And the only way to do that is to get on the laptop and have a look at the MiRo. It's quite attractive. You can see it's got nice different colours and it looks quite easy to use. So even children who wouldn't usually go to coding, we have seen quite a lot of children who, well, the majority of children on our holiday programs, they all want to do it because they want to make MiRo do something fun. And it's a nice looking code, so they come and they start to then use the MiRo code on the laptops and then see it on their simulator and also see it on the robot. Whether it's online or whether they're in classes, they can still see it on robots either through our cameras, or they can actually download it directly if they're here in our centre. And I think, Tony, you've managed to do some workshops in Beck Primary School.
Yeah, so we're working with a school in Sheffield that's in one of the more socioeconomically sort of challenged areas of Sheffield. So they've got a wide variety of kids. A lot of them don't have computers at home. And we've done some classes with MiRoCLOUD where they program the robot, and then they send the programs that they've written, because you can save your code in a little program, send it in an email, and then what we do is run their code on the robot at Sheffield Robotics Lab, and they see if it works or not. So we had this little competition with a pile of cups that they have to knock down by getting MiRo to drive into it, which is a great little challenge to do. It's 4 or 5 lines of code, but of course what happens in the real world is always slightly different from what happens in simulation, so you never quite know whether it's going to hit them full on or miss slightly. So that's a great thing to do. And of course, if you've got MiRo in the class, you can just click on the button to make it run on the robot, which is even more exciting to do it live while you're there. But in these difficult times, you can do it remotely, and that's an exciting way to do robotics. And we're going to be trialing that at university as well, with students writing their code at home or in their halls of residence, and then sending the code to be tried out on the robot, and they can watch over Zoom to see how it goes.
And obviously, children who we work with have chosen to come here to do robotics specifically. So or they've chosen to do STEM subjects. So we do kind of expect that that's the kind of young people that will be interested in coding and robotics anyway. But when you're working in a school, so teachers in a school like Beck Primary, they've got their whole class of 32 children who are all very different. But I did hear some feedback from the teacher in that school that his whole class were really excited and they were all involved and they all took part. And next month we'll be starting to do teacher training with 9 teachers from other schools around Sheffield. And so it would be really great to feedback from them after they've done their teacher training next month, and they're able to start using either just the MiRo code in their classroom, or if the children have to go home, then they can still do that remotely from home. They can still help their children to support, they can still support their children to use MiRo code through their Google Classrooms, and they will still be able to access the learning. it'll be really interesting to find out from those other schools whether all of the children are engaged, because so far we are just seeing a lot of children who are really excited, regardless of what their background is.
Yeah, I mean, I think the distance learning possibilities are really quite exciting because one of the reasons we made MiRoCLOUD, before it was MiRoCode, it was an application, you installed it on your computer. Now MiRoCLOUD, so it sits in the cloud, you just open a browser window and you log in. And the great thing about that is that you don't have to have a new computer, one that's fast and new, because all the hard work is being done in the cloud, and it will run the same speed on any computer. So I think that makes it much more accessible. Also the installation time. So even with students, we found in the past that if something takes 15 minutes to install on your computer, and then there might be issues because you've got a different version of Windows or whatever, that's all a big barrier to people getting engaged with the learning. So now it's the same for everybody, just any browser window, log in, it will run, and it will run, you know, you load it up, just takes a minute or so, and then it will be running, and you can start programming. So it makes it much more accessible.
Yeah. I mean, it's fantastic, because at the moment there's such a need for that kind of blended learning. You know, schools need to utilize home teaching, studying, and yeah, we're trying to alleviate that logistical struggle as well as kind of keep those students motivated. It's something a bit more interesting. I mean, Tony, using the kind of same technology, so as we've mentioned, we've got the MiRo robot, we've got the Blockly kind of coding which you showed earlier, and Python, and you've said that you're using pretty much the same technology in your undergraduate level as Melissa's using at age 6, which is incredible to me.
Yeah.
Do you think that's an important kind of process to be able to kind of see it transition all the way through?
Well, I mean, if you're a beginner, you're a beginner. It doesn't matter what age you are. And, you know, so, and university students face some of the same challenges. If you've never programmed before, you need something which will give you a gentle ramp in, which is what Google Blockly does. I mean, they pick it up quickly and they're learning Python alongside. And in level 3, we actually have kids that are, well, students, these are 20-year-olds, I guess now, that are quite advanced, that know about AI, that know about neural networks, that can actually program some new functions into the robot. And so, you know, the skills go up a huge level and quite quickly. You know, we have level 3 students programming MiRo to play football or to do telepresence. We had a project with that, so remotely controlling robot by telepresence. And we have master's students working on this, postgraduate students. So it goes right the way through education. And of course, for us, MiRo is an important research tool. And we're looking towards applications in assisted living and healthcare, alongside a lot of university partners and hospitals, particularly children's hospitals, very interested in using MiRo as a tool to help calm children that have come to hospital and are perhaps upset or worried, and you can distract them with the MiRo robot. So it's a therapy tool and a healthcare tool besides being an educational tool.
And the things that Tony has just spoken about are the things that make MiRo all the more exciting for young people to use in education, because we can show them how MiRo is being used in the real world to solve real problems in the medical world, and that universities are doing this high level coding and programming to help patients and work in the help the hospitals. So when they use MiRo and we kind of give them the same sort of problems, they feel like they're doing something really important. They can see that the universities are using the same robot and coding it to do really important things. So they feel as though they are part of that, and they're doing something that has real context and is really exciting, and they feel like they are heroes, like all of the academic researchers at the university. They're part of the same community doing the same thing.
Oh, it's great.
The sort of dual role that MiRo has as a teaching platform, but also, you know, as a pastoral tool, is really quite exciting from the perspective of schools, because schools in the past had classroom pets, but they're becoming less common now because of concerns about animal welfare and allergies and so on. And MiRo is quite a lot like a classroom pet. You know, if you imagine you had a rabbit in the classroom and kids, if they're a bit upset or anxious, could go and interact with the rabbit for a few minutes, and that has a calming effect. We think that MiRo can do the same thing. And we also now have children in the classroom who might have, sort of be on the autistic spectrum, and we found that those children also can find MiRo to be really engaging. And so we're looking at it as a therapy tool to help children with special educational needs, as well as more broadly as this education tool to teach anybody about coding. And we took it to a school assembly where there were a number of children with special educational physical disabilities, and they were really engaged with the robot, and they could have it on their lap and stroke it, and it sort of really helps, I think, to bring those kids into the group and into the class to feel they're part of the larger group.
Thinking back to my days when I used to work as a full-time school teacher, some days were really, really stressful, and 10 minutes at lunchtime with a cup of coffee and MiRo would have been wonderful.
Oh.
Yeah, we've had some teachers saying, yes, we want one for the staff room.
Yeah.
Yes.
I'm sure that when people can't find MiRo, it's going to be in the staff room.
Oh. Well, I think we're coming close to our end of the session. I mean, it's been fantastic hearing about what you've been doing, Melissa. I mean, just a great company, great, like, it's the work you've been doing and support for training for teachers and the work with the kids. It's all incredible. And Tony's always great to see Tony and know about what Tony's been working on. So I'd like to thank you both for coming. So that was Melissa Butt and Tony Prescott. And yeah.
Thank you very much, Izzy.
Thank you.
Thank you.